I believe that was the last part of 3. So now we move on to problem 4. Okay. Now, for problem 4, we have one. It says, suppose you continue to draw a single card from a shuffled deck until you finally obtain an ace. So this is one of these instances where you're looking for the very first occurrence of an event after you perform a procedure trial by trial by trial. You're looking for the first occurrence of an event. In this case, the event is the event that you draw an ace. So we're going to draw a card from a sufficiently shuffled deck, and we're going to continue to draw cards until we finally get an ace. So this means the first occurrence of getting an ace. And that could happen on the first draw, it could happen on the second draw, it could happen on the third. So we're looking for a situation where you draw cards until you get the first occurrence of an ace. And we have a table for a first occurrence of an event occurring when you repeat a procedure trial by trial, and that's table 1F. So table 1F is the table that we use when we're doing these first occurrence of an event occurring after repeating trial by trial by trial and repetition, and we're looking for what trial did the event E first occur. And that table is divided into rows based on the number of trials it takes for the first occurrence of the event A. So if you refer to table 1F, that's the table we're going to use to solve this problem. Now, if you look at part A, it says, what's the probability that you will draw an ace for the first time on your second draw? Well, according to the table, that would say that the trial for the first occurrence of the event is the second trial, because we're saying what's the probability the first occurrence of an ace happens on the second draw. So here our capital N, which is the trial where you get the first occurrence of the event E, is 2. So we're looking at the second row of our table. And we also need to know the value of little p. It says on table 1F that little p is the probability that the event A will occur in any one trial. So here, little p would be the probability that you'll get an ace on any one given draw. And we know from 3a, the probability of getting an ace on any one draw was 1 over 13. So we're saying with the second trial being the first occurrence of an ace, and the probability of getting an ace on one trial is 1 over 13, what's the probability that the first occurrence of an ace is on the second trial? Well, you can look at the formula from the second row, which says that that probability, capital P, is going to be 1 minus p times p. That's the probability that the first occurrence of the event happens on the second trial. And here our little p is 1 over 13. So all we have to do is plug in 1 over 13 into the formula from the second row. And that will tell us the probability that our first occurrence of an ace happened on the second draw. So you can just plug 1 minus 1 over 13 in parentheses times 1 over 13 directly into your calculator. As long as you make sure to use your parentheses, you can enter that all into your calculator and hit enter. And what you should get after doing that is 12 over 169, but as a decimal, what will come out is 0.07101. So rounded to 4 significant figures, if you plug that in your calculator and round to 4 significant figures, the answer is the probability that you'll get an ace on your second draw for the very first time is 0.07101. So that is the answer to part A, for part A. Now let's look at for part B. In problem 4B it says, what's the probability that you will draw an ace for the very first time on your third draw? So now it's saying, what's the probability that it would take 3 draws to get the first occurrence of an ace? That you'll get your first occurrence of an ace on the 3rd draw. Well, here using the same table, now we're looking at n equals 3, which is the 3rd row. Because the first occurrence of an ace happens on the 3rd draw. And if you look at and of course, once again, the little p is 1 over 13, which is the probability of getting an ace on any one draw. And the formula we need from the 3rd row is 1 minus p to the 2nd power times p. And this, of course, is also the same table that's on page 305 of the book. Now, so if we plug our p equals 1 over 13 into our calculator, we'll get 1 minus 1 over 13 squared times 1 over 13. And if you plug that into your calculator correctly and hit enter, that will give you the decimal 0.06554. So to 4 significant figures, this gives, so it says the probability that you'll get an ace on the 3rd draw is 0.06554, rounded to 4 significant figures. So that's the answer to part B. Now if we go to part C, which is the last part of problem 4, it's the same kind of question, but now we don't say on, we say by. It says, what's the probability of obtaining an ace for the first time by the 3rd draw? So this is not the same as saying what's the probability of obtaining an ace for the very first time on the 3rd draw. If you change that word on to the word by, this now becomes a compound probability statement, like we said in class. To say the probability of obtaining an ace for the first time by the 3rd draw means that's the probability of obtaining an ace for the very first time either on the 1st draw, or getting an ace for the first time on the 2nd draw, or getting an ace for the first time on the 3rd draw. So saying by the 3rd draw means that either the first occurrence of an ace had to happen on the 1st draw, or the first occurrence was on the 2nd. So this turns into a compound statement. And it's not possible to get the first occurrence of an event to happen on the 1st draw and get the first occurrence of an event to happen on the 2nd draw at the same time. So the compound statement you get here is going to lead to mutually exclusive events. So you now have the addition rule for mutually exclusive events here. So instead of just looking at the formula from the 3rd row, since n is 3 here, you have to look at the formula for each row leading up to the 3rd row in that table. It's the probability of either getting your ace for the first time on the 1st draw, which is just p from the 1st row, plus the probability that you're going to get your ace for the first time on the 2nd draw, which from the 2nd row is p times 1 minus p, plus, make sure this all fits in here, plus the probability, well, you could write it as 1 minus p times p to be just like the table. Doesn't really matter. And then plus the probability that the first occurrence of an ace happens on the 3rd draw, which is 1 minus p squared times p. So instead of just using the formula from the 3rd row, you have to use the formula from each row prior to the 3rd row and then add them.
Hi, my name is Linda Carter,
Yes.
and we're supposed to test in here
Oh.
at 11
Okay.
to 2.
Okay, well, I'll go ahead and stop then, and I'll finish this. I didn't realize, because they said I could use this room, I didn't realize that.
Yeah, until
Are you
11.
Marcia?
No.
Okay. All right, I didn't know that. I'm going to go ahead and end this, and then I'll just go to another room.
Okay.
Sorry about
Cool,
that.
cool.
All right. It turns out that somebody needs this room, so I'm going to go ahead and finish here, and then we'll finish the rest of it in a second video. We'll pick up where we left off here on problem 4C, and then we'll continue in the next video segment, because I have to move to another room. All right. well, so this will end this first part.